So in today's math video, we're going to figure out the equations of a sinusoidal graph. So this is where I will give you a wave, and you are going to figure out the actual equation of the function using sine and or cosine. So here we have a sinusoidal curve, and so what we're going to do first is figure out the max and the min. So the max here in our case is the highest y value. In this case, it is 4. The minimum is going to be down here, which is -6. And once we have our max and min, we can figure out two pieces of information. We can figure out the equation of the axes. Recall that equation of the axes is the line that cuts the horizontal line that cuts the graph in half. And also we can figure out the amplitude. So let's start off with the equation of the axes. Equation of the axes is the midpoint between the max and the min. In other words, it is 4 plus -6 divided by 2, and that's going to give us -1. If you don't like to calculate things, you can actually take your graph, look at the graph, and figure out the number of boxes in terms of vertical boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know from here to here is 10 boxes. So the middle part, the middle line will be 5 boxes. 1, 2, 3, 4, 5, right over here. So what I did here was just from a graphical point of view, or if you prefer, you can actually take it from a numerical point of view. So I'm going to just draw the equation of the axes using a blue color. So over here, I'm just going to draw here so we can clearly see that this is the middle line. And once we have the middle line, we can actually look at our graph and figure out what the amplitude is. Amplitude, remember, is the vertical distance from the max to the equation of the axes, or from the minimum to the equation of the axis. In this case, I'm just going to count the number of boxes, and I'm aware that each box has a value of 1. So that means 1, 2, 3, 4, 5. So my amplitude is 5. Now, some students would want to actually calculate this using these two numbers. To calculate this, all you have to do is take the max minus the min and divide it by 2. So I'm going to take 4 minus -6 divided by 2, and that's going to give us 10 over 2, which gives us 5. So as I said, there's two different ways to calculate the amplitude equation of the axes, visually, or you can use numerically. So now we have the actual A value. I'll put here the A value for the cos or sine, depending on which we're going to be using. And here we also have the Q value. So we have the A and the Q, which are the vertical parts, the transformations of the function. Now we're going to have to look at the horizontal. Now, what kind of horizontal feature can we look at from this graph? Well, we can actually look at the period. So remember what I said, period? Period is the horizontal distance of one cycle. So this is where you have to sort of pick, what do you want to work with? Do you want to work with sine or cosine? So let's actually start off with cosine. So cosine, if you recall, cosine starts off as max, min, and max. So I'm going to just use a blue color pen and start from the max. In this case, my max is over here, and all I'm going to do is trace out one cycle. So over here, all the way up here, and this is one cycle. If I keep on going, that's going to be starting the second cycle. I just want one cycle. And all I'm going to do is figure out the beginning point and the ending point. So the beginning point is 90, and ends up at 450. So I'm going to subtract these two numbers to figure out the period. And if I subtract them, I'm going to end up getting 360 degrees. And since we're talking about the cosine graph, now the cosine graph starts off usually on the y-axis over here. Usually it would start up here, but now I can see that there's a slight shift to the right. By how much? Well, it's shifted from the y-axis all the way over here, which is the 90. So it's actually shifting 90 to the right. So once we have all this information, we can figure out the equation of the cosine. So over here, I'm going to put cosine. And then after that, I'm just going to put the A value. A comes first, which is my amplitude, which is 5. And since I'm starting up here, it's a positive 5. What happens to my Q value? Q value is going to be -1 over here. Now let's fill in the rest of the parts here. So the number outside here is my K value, and the number inside here is my phase shift. So I know I'm shifting 90 degrees to the right, so I'm going to put here X minus 90 degrees. That means I started to move 90 degrees to the right. However, how do I calculate my K value? A lot of students might put, oh, I'm just going to put 360 in there. Now 360 is not the K value. The K value is the factor from is a stretch or a horizontal stretch or vertical stretch from the original cosine graph. So what's the period of the original cosine graph? Well, going back, it's 360. But what's our period for this graph? Oh, it's 360. So there is no horizontal change. No stretch, no stretch factor, no compression factor. So K is neutral. It is 1. Now, some students might be like, well, I don't want to start from the max. I want to start from the minimum. Is it okay if I start from the minimum? Of course, you can start the cosine graph anywhere you want in regards to the top or the bottom. So in our first example, we started up here, but the cos graph could start at the very bottom. So you got to pick which one you want to start. You want to start from this perspective or from this perspective. It doesn't really matter. So let's actually start from this one here. Let's start a little bit to the left of the y-axis. So let's do this one here. So I'm going to trace it out with a green one. So green, and then I'm going to trace it out from here. And what happens here? So I'm just going to trace out one cycle. So all this scribble stuff here is one cycle. Now the question right now is, has the period changed? No, the period is still 360. The only difference right now is the shift, because usually the cos graph starts on the y-axis, but now our graph has moved a little bit to the left. Well, how much? Well, we've moved 90 degrees to the left. So in other words, our second equation, possible equation, is the amplitude is still 5, the period is not changed, and the amplitude, the equation of the axis is still the same. So these don't change. However, the shift has changed because now you started at the bottom and you move 90 degrees to the left. In other words, it's going to be x plus 90 degrees. But hold on, miss. You said you started at the bottom, but doesn't the original graph start from the top up here? You're absolutely right. So now we need to take into consideration that there is a flip, because the original cosine begins top, bottom, and top, but now we start at the bottom, so we're going to have to compensate this with a negative. So notice how we have two different equations, but they represent the same graph. But miss, I don't want to start here. I want to start over here. Well, if you started here, so that means this is considered your one cycle. That means you actually shifted how much to the right. Usually the cosine graph starts here, but now you move 270 to the right. So another possibility is the following. So everything's the same thing because you're starting at the bottom, but now you shifted 270 degrees to the right. So here we have three possible cosine equations. So the next thing is, well, miss, I don't want to do the cosine. I want to actually work with the sine. And of course you can work with sine. So sine, well, where does sine usually begin? The basic graph. So over here to the right, sine begins on the equation of the axes. So in other words, for our sine, if I wanted to trace out an upper bump and a lower bump, or a peak and a valley, I would start, there's many places you can start. I'm just going to start over here for one example. So I'm just going to trace out the upper bump, or the peak of the sine, and then the valley of the sine. And here is one cycle. So as you can see, the cycle is no different from the previous example when we use the cosine. The period is still the same. It's still from 0 to 360. So in other words, even the amplitude is the same. Nothing changes in terms of the amplitude and the equation of the axis. It is still 5 from before, and there is the -1. And over here, the k value is 1 because it's still 360 for the 360. But over here, well, is there a shift if I started here? Well, now if you notice here, this specific graph, sine graph, starts on the y-axis, just like the original graph. In other words, there is no shift. If there's no shift, it's just a simple x. Now, there's also another perspective. Some students want to start over here. I'll use red. Miss, I want to start over here. And I want to go upper bump and then continue on with the lower bump. What that means is usually the sine wave starts here on the y-axis, but now you shift it all the way to the right by 360. So another option is to take this graph and move it to the right 360 degrees -1. Some students might want, well, miss, do I always have to start with upper bump and then lower bump? And the answer is no, you can start from the lower bump to the upper bump. In other words, you can start, for example, let's start I'll use blue over here. I'm going to start here. I'm just going to trace one cycle. Here's my lower bump, and then here's my upper bump. So in other words, the amplitude is still the same. Oops, it should be sine. Over here, it's still -1 equation of the axes, but now you started going down and then up. But when you go down and up, that indicates that there's a reflection. But which reflection? there's actually, for sine, you can have two possibilities. In other words, you can have a reflection on the x-axis, or if you really wanted to, you can have a reflection on the y-axis where the k is -1. And in this case, we do have a shift. Well, what's the shift? Usually sine starts here, but now we are shifted 180 to the right. In other words, x minus 180 degrees. So here we have four different looking equations, but they represent the same curve. So we're just going to go through a couple of more examples, and I think right now is a good time to pause the video and see whether you can answer the max, the min, the amp, see if you can answer some of these questions. All right, so let's take up some of these answers. My max is going to be 6 because the max is over here. My minimum is over here, which is 4. And based on the graph, I know that this line here, I'll just draw it in red. This line here is going to be my equation of the axes. In this case, is going to be 5. 5, or y is equals to 5. For those that want to calculate it, it's 6 plus 4 divided by 2, which is 5. So you take the max and min, add them together. Now, if you want to find the amplitude, I'm just going to take 6 minus 4 divided by 2, which gives me 1. Or I can just look at my graph and see, oh, the distance, the vertical distance of the bumps are actually 1. Let's look at the period right now. So the period, and let's actually work with either sine or cosine. I'm going to work with sine. So I'm looking at sine here. Sine begins on the middle line. So the middle line is going to start over here. So I'm going to start over here. There's my upper bump and there's my lower bump, because that's where I want to start. Maybe where you started is different for the sine wave. So the sine wave starts at 90 and it ends up at 270. So my period is going to be 270 minus 90. I'm going to end up getting 180 degrees, I believe. Yes, 180 degrees. So, and since I'm going to deal with the sine wave first for my particular choice, I actually moved 90 degrees to the right because that's where I started. But here, 90 degrees to the right. And over here, the period, you got to figure out the k value. So the k value, well, the original graph used to be what? 360 degrees, but what happened? Oh, it's actually compressed. So when it's compressed, that means it's compressed by a factor of 2, because 360 divided by 180 is going to be 2. So that means the k value is going to be 2. Now, I'm going to put in the bottom for here. So here's a general equation to find the k value. It is 360, should be 360 divided by your period of the function here. So in this case, I had 360 over 180, and that gives me 2. So for my sine equation, I'm going to do the following. I'm going to call this sine. What's my a value? My a value is 1. You don't really have to put a 1. Sine. My k value is going to be 2. I'm going to open bracket because I did say I have a shift to the right degrees. And what's my equation of my axes is going to be plus 5. Another perspective for sine is I'm going to start on the y-axis, but instead of going up and down, I'm going to go down and up. So a possible equation is going to be the following. Because I went down first, that means there's going to be reflection on the x-axis. I put -1, but everything else is still the same. However, I do not have a shift, a phase shift, because my sine wave actually start on the y-axis. So I'm just going to put an x here. Some students would like the following. Can I not put the negative on the 2? And the answer is yes, of course you can put it on the 2. Because a single reflection, either on the x or the y-axis, the graph will start going down and then up. Let's talk about the cosine wave. So the cosine wave, remember what cosine wave means? Usually the basic graph cosine starts on the max, or if you want to be creative, you can start on the minimum. So for me, I'm going to choose the minimum. I'm going to choose over here. So my cos graph is going to start low, minimum, maximum, and then minimum. The period is still the same. You will get 180, so the k value is the same. The amplitude is the same. The max mins don't change. So a lot of things do not change. The only thing that changes in terms of between sine and cos, it is the shift or the reflection. So in this case, for my example here, the amplitude is still 1. I still have a cos. My k value is still 2. The question is there a phase shift? And then my equation of the axis is still plus 5. Okay, so do I have a phase shift? So over here, I'm going to say I do because my cosine graph, I decide to start here, right over here. That means I shifted to the right 2 boxes. And I know I have to look at the scale. From here to here is 90. That means 45. That means I shifted 45 to the right. In other words, x minus 45 degrees. But miss, I don't want to choose here. Some students want to prefer to start on the top, on the maximum. So if you chose the maximum, you need to figure out which one you want to use. I'll use yellow color just to start it off. I want to start here. I want to start backwards. So some students might choose this one here. I'm just going to scribble this one here. In other words, if you want to find this equation, it would be this exact same thing. The a value is the same. You got the 2 over plus 5. Actually, I made a mistake for the other one because in the other one I started at the bottom. I need to put a negative there. But now because I'm starting at the top, I don't need to. I'll put it as a positive. I don't really need to put it as a positive. Now the question is there a shift? Well, yes, there is, because you shifted to the left 2 boxes, and 2 boxes is worth 45. So that means I'm going to put x plus 45 degrees to the left. So in this example, I'm trying to show you as many possibilities, and just because my answer is different from your answer, it doesn't mean yours is wrong. So for the next one, I'm just going to reduce the number of possibilities because I don't want to make this video too long. So let's move on to the next one. So I want you to pause the video and see whether you can figure out all these key features. Okay, so here are the answers. The max is going to be 5 because the maximum is over here. Minimum is at -5, and I can see that the x-axis is my equation of the axes, and that's why the equation of the axes is 0. And the distance of the upper bump over here versus here is going to be 5. Now the period. I'm going to start it with a sine curve. So sine curve for me, I'm going to start doing the peak and the valley for me, for my choice. So I'm just going to color this so everyone can see in green. Over here, this is my peak. And this is my valley, and for my particular case, it seems like the sine wave has shifted a little bit to the left by 30 degrees. So I'll put here 30 degrees to the left. And because I'm going to say here, I put up and then down, that means I do not have any reflections. Now, in my equation here for sine, I'm just going to put the a value, which is my amplitude, my sine, which is sine here, and my k value is 2, bracket, bracket, and my phase shift is going to be 30 degrees to the left, 30 degrees. And then do I have an equation of the axes? And the answer is no. So I'm just going to leave it blank. I don't need to put a 0 plus 0 here. So let's have a look at the cosine shift. So cosine shift, I'm going to choose max. I'm going to start at the highest point of the max of the cosine. So max, min, and then max. I don't really have to draw out the entire cycle because I already know all the features. These numbers do not change. So in other words, my y is cosine is going to be still 5. Cosine is going to be pretty much the same thing as the sine, all the AKs. The shift is going to change, and obviously these are going to be the same. The Q values are the same. Now here, my shift is really, really little. It's like a box. So in other words, my cosine has shifted a little bit to the right by 15 degrees. So x minus 15 degrees, in my case, is 15 to the right. So as I said, my answers could be different from your answer. It really depends on where you want to start. If you wanted to start over here, then for the cosine graph, that means you're going to have a negative number in front of your 5, and your phase shift will be a little bit different. It'll be to the left in this case. Or if you started to choose over here, so you would have a -5 instead of +5, and you'd be shifting 105 to the right. So again, pause the video and see whether you can figure out the features of this sinusoidal wave. All right, so the max is over here, and over here this number is -1, and the minimum is all the way down here, which is -9. And then our amplitude is +4. Keep in mind, amplitude is the distance, it must be positive. So I can see there's 4 boxes here from the max to the equation of the axes, and each box is worth 1. All right, let's figure out the period. So I'm going to start off with the sine wave. I'm going to trace a sine wave out in this case. So I'll use green. I know that sine wave begins on the equation of the axes, the horizontal line that I just drew in black. So I want the sine wave to start as closest to the y-axis for my choice. So I'm going to start over here, right in green. And so it's here, the number here is going to be negative 45. And one wave takes, here's my upper bump and my lower bump. And in my case, I cannot see where it ends. So in this case, I'm going to stay away from sine for a while, or you know what? Actually, because I can't see the entire cycle, I can see at least the first part of the cycle. So I can figure out half the period and then double it. So over here, I start at negative 45 and half my cycle ends over here. So this number here is going to be 315 because every 2 boxes is 45. So what I'm going to do right now is to find the distance of the period. In my case, the period is going to be 315 minus 45 because there's a double negative, which is 315 plus 45, which is the same thing as 360 degrees. Now, 360 degrees is not one cycle. It is half a cycle. So that means for the entire period, I'm going to have to double it. So times 2, that gives me 720 degrees. So the period is 720 degrees. So what is my K value going to be? So the K value is going to be 360 divided by 720, and that's going to give me a half. So this is our first time in this example, in this video, seeing where the K value can be a decimal or a fraction. So let's actually figure out the phase shift for sine. Now sine here, I started over here where the black dot is. So it seems like I'm starting 45 to the left. So put here 45 left. So if I have to write my equation, number 1, I started with the amplitude, which is 4. I do my sine. And then I'm going to put the K value, which is 1/2. And inside this bracket is the shift, the phase shift. That means I move 45 degrees to the left. And the last number is going to be my EOA, minus 5. And the last thing we're going to do is the cosine. So the cosine, I'm going to choose the one up here, right over here. And I'm just going to I'm going to just trace it out. And I can't trace out the whole thing. And it doesn't really matter if I can't trace out the whole thing because I already have the period already from the previous calculation. So in other words, my graph for cosine is going to be the same thing. It's 4. The reason why it's not negative 4 is because I start at the top, not at the bottom. My K value is the same thing as the sine. The shift will be different, but the equation of the axis is the same. So what is my phase shift? So in this case, cos usually starts on the y-axis up here, but now it's shifted how much to the right? It has shifted 135 degrees to the right. So x minus 135 degrees. So when I give you a graph, you should actually make sure you know what's the value of the scale of each box.